ado, Fred can talk about his recent passion of freshwater mussels.
Okay, so I guess I'm on the screen, and now when I took public speaking as an undergraduate, they told me never to apologize. So I'll just say that the dynamic tension in the talk you're about to hear comes from the fact that I haven't seen it projected before, and we don't have any text because Aleta had to put it together very quickly last night. So my idea here is to use the endangered freshwater mussel, native freshwater mussel, Legumia nasuta, which is variously known in English as the pointed sand shell or the eastern pond mussel. And since it doesn't live in either ponds or sand, both of those names are defective, and the scientific name Legumia nasuta is so cool that I just call it that. And basically just to talk about its abundance on the Frontenac axis and how we only know that this population exists because of some accidental encounters between us, meaning Aleta and me, and the species. And I'll see about pushing the right arrow, or that's the left arrow. So if you can, I guess you can see, can you see that okay? This is most of the freshwater mussels we see are a species called Elliptiocomplanata, and I could talk for an hour and a half about the different species, but I'm not going to talk about the different species. But most of the species we see, most of the shells we see of mussels are Elliptiocomplanata, which is a flat, sort of oval, brown mussel with purple nacre, the mother of pearl, inside the shell. And the name Legumia nasuta means nose, and it refers to this nose-like end, posterior end of the shell. And so, without going into the identification in detail, that's how you recognize nasuta. Now, there's a whole lot of different bivalved mollusks, clams and mussels and stuff, and they have a real paucity of English names because there's basically clam and mussel and cockle, and those were the marine kinds that were eaten in England when English was being worked up. Now this is a recently published phylogeny, evolutionary tree of all the bivalved mollusks, the bivalves, and I just want to show that the freshwater ones here, the unionids and their relatives, branch off way back. This is back in the Paleozoic, and then we have mussels, and a mussel is of course we call them mussels. The unionids we call mussels. This is the English as a defective language to talk about bivalved animals. But one of the basic ancestral abilities of bivalves is the ability to spin little threads of protein and attach themselves to their substrate. And the classic example of this is Naturalist, the blue mussel of commerce and eating. And that's up here on the evolutionary tree. But then there's also the dracenids, the zebra mussels, which has the same lifestyle. It has pelagic larvae floating in the water, and then attaches to substrate and spins these byssus threads, as they're called, to attach itself. And it has the same shell shape as a marine Naturalist mussel, but it's way down here in a totally different branch of the evolutionary tree. So names are a real problem. There's been an attempt to call these naiads, but from a Greek word about a water spirit, but it hasn't ever caught on, and I understand the problem is just as bad in French as it is in English. Oh. Now, this is a painting Aleta did of the situation in the Ottawa River about a species of mussel right here called Abavaria olivaria. The adaptation that these freshwater mussels developed back in the Paleozoic was an adaptation to live in fresh water. Now, we think of freshwater in Ontario as being lakes. I mean, we think of it to the extent that the Ministry of Natural Resources just sort of comes apart in fisheries management when you just have rivers, because we think of freshwater as being lakes. And that's because we had all this ice, 10,000 years ago, grinding holes and everything and putting up dams. But the natural condition of fresh water is just to be a river all the way from the headwaters down to the ocean. And so if you're going to live in fresh water, you have to be able to move upstream at some stage in your life cycle. And a lot of the freshwater organisms are either able to swim, like fish, and fish always swim upstream by choice, or else they have an adult stage, like insects, where you get this constant drift of larval insects down the stream, and then when they become adult, they just move upstream against the current. But, well, I mean, they're flying, yeah, because they're flying adults. But if you're just living in the same square meter of stream bottom for your whole life, and if we have an event like last week, you may get swept 3 kilometers downstream, you've got to have a strategy. And the strategy is that the males release sperm into the water in the same way that marine mollusks do. And the females suck the sperm in, but instead of the females releasing their eggs into the water to be fertilized in the water column, the females suck the sperm in with their normal feeding. That fertilizes eggs that are on their gills, which are called a marsupium, because the embryos develop on the gills of the female and get to be sort of sub-millimeter size, and their shells are just like little jaws. And then, depending on her species, the female does something to lure some large vertebrate animal capable of moving upstream within range. And she may look like a dying crayfish, or she may look like a wounded minnow with mantle flaps that stick out of the shell. She may even get up on the surface of the water and the surface of the bottom and flap around and get eaten. She may make one of these, a natural form of these artificial gummy worm baits that fishermen use, called a conglutinate in that case. But all these things are packed with babies. And so the fish comes in because it thinks the mother looks like something edible or smells like something edible, and then she just sprays him with babies, and they clamp on with a little Pac-Man. Oh, and the snuff box is one that just grabs the fish with its shell and clamps onto the face of the. Now, the other thing is that it's not just any fish, that it's only particular species of fish will be a suitable host. There's some kind of complex immunological reaction that limits this host species. And in the case of the Abavaria here, the host fish is the sturgeon. And so you have the situation where one species at risk depends on another species at risk for its survival. And it takes considerable effort and research to determine what these host species are. And in the case of Legumia nasuta, which was a common species, it was really, really common. It was the 5th or 6th most abundant species in Ontario before the zebra mussels came in. it was common, and its host fish had never been studied. And let's see what we'll go back for. So the other theme of this is how little we know about the distribution of so many organisms. And Owen has sort of warmed you up with that in terms of all these rare trees where, you know, they were commercially logging red spruce in Algonquin Park before it was recognized that they were red spruce. And since the red spruce wood is more valuable than the white spruce, they were probably overexploiting the red spruce relative to the white spruce before it was recognized what the species difference was. Now, those of us who consider humanity to be a single entity interacting with other species that it lives among consider it the primary responsibility of humanity to know who its neighbors are. And since Darwin, they're not just neighbors, they're also relatives. And so it's perhaps regarded by some people as eccentric to regard the National Museum or Provincial Museum as the main instrument of human sovereignty over a territory. But that's where we're stuck, so that's why we do what we do. Now, in the United States, there was this guy in England called George Smithson, who had, what was it, 500,000 pounds, which he gratuitously left in his will to the United States government to start a national museum. And so the National Museum of the United States is a Smithsonian institution, and it's always had a certain endowment from Smithson's original, however many thousand pounds it was, that ballasted it against the vagaries of government irregularity. So they can always use their own money. Whereas in Canada, since its foundation around 1831 or so, the Geological Survey and the National Museum, which was its offspring, have always just been dependent on what Parliament thinks is important. And Aleta and I happened to start hanging around the National Museum in the 1970s when understanding what was going on was supported relatively generously. The National Museum, you know, they built the Victoria building, the Victoria Memorial Museum building in Ottawa in, I think, they had it done in 1914. Then in 1916, the Parliament buildings burned, and they had to move the Senate into the museum building, so the museum sort of went into the back corners of its building through the 1920s. And then there was the Depression and World War II, and around 1950, things started up again, and we started to hang around just at the crest of this wave, so there's sort of a sine wave curve of the history of the National Museum of Canada. And this is a label from the museum when they started to repair the Victoria Memorial Museum building in Ottawa for the centennial celebrations in 1967. And so everything was moved out, and the museum was dispersed to a whole bunch of different buildings around Ottawa, which meant there was less central control, and the collections grew to the point where even if they'd fixed the building in time for the centennial, and they didn't get the foundations rebuilt until 2010, which was something somewhat delayed for the centennial celebrations in 1967. Anyway, so we started to hang around the museum in the one of its florescent periods when people were actually going out and studying the distribution of stuff. But it's a really big country, and it requires an awful lot of people who know an awful lot about the identification of a huge number of species in order to get any idea what's going on in Canada. So part of this fluorescence of the museum in the 70s was sending Arthur Clarke, who was a malacologist from Harvard, sending him out all across the non-St. Lawrence drainages of, well, the interior basin, they called it. Everything that drained into Hudson's Bay or the Beaufort Sea. And so he went all across the country and collected freshwater mollusks, snails and clams, and produced this book, which was that was a standard product of the Biological Survey of Canada, which, there's birds of Canada, mammals of Canada, and mosses, and a whole number of taxa that were coming along until, now I'd like to say that until the curators started to publish lists of rare and endangered species in Canada. And just coincidentally, about 5 years after the curators started to publish lists of the rare and endangered species in Canada, the museum went into a long-term decrease in funding, which has left it not really able to do the Biological Survey of Canada. But this is Arthur Clarke's book on the freshwater mollusks of Canada, and Aleta's paintings of these freshwater mussels, and here's Lagumia nasuta, which we thought of at the time as just a species that was common in the Great Lakes. That's before the zebra mussels. So this is a juvenile raven in front of a gravel pit on the Quadra Sand on Vancouver Island. And we were out on Vancouver Island in 1989 when the cutbacks, the museum stopped accepting specimens basically. And a couple of years, well, actually that next year, we did the last expedition that was done for reptiles and amphibians by the museum. So then, about the same time, these zebra mussels were introduced from Europe, and as you all know, took over the Great Lakes, the St. Lawrence, and one by one, all the lakes in this part of the world. This is a painting of drifted stuff from the beach at Port Dover and Lake Erie in 1992, just when the mussels were still being killed. And this is a Lagumia nasuta, which was the population of Lagumia nasuta in Lake Erie was estimated at somewhere between 3 and 6 billion.
What does the zebra mussels do to it?
Okay, the zebra mussels attach to any hard substrate. They have these little planktonic larvae. The sperm and the eggs get together in the water column, and they form little larvae that live in the water for 2 weeks to 2 months, depending on the temperature and stuff. And they settle out and attach to any hard object in the water. And that includes the shells of freshwater mussels, which have the added benefit that the freshwater mussel the native mussel is pumping water past, and that's a free lunch for the filter feeding of the zebra mussel larva. And so the huge mussel populations and diversity of the Great Lakes was just sort of wiped out. Starved and suffocated. And when we do mussel recovery planning now, we don't even consider the Great Lakes as potential habitat. It's sort of a black hole dead zone. So this is a book we did in 1994 when shells were still washing up on the beaches of the Great Lakes. And we walked along the Lake Ontario waterfront from Hamilton to Trenton. And it turns out we picked up a Lagumia nazuta shell at the mouth of the Rouge River downstream from the Toronto Zoo, which was a previously unknown population. And then in 1995, the Ministry of Natural Resources got motivated to do something about mussels because they were losing so many species, and they had contracts. There was a contract for the Sydenham River down southwestern Ontario, and one for the Grand River from Guelph down to Dunnville, and then there was one for eastern Ontario because there was one rare mussel in the Ottawa River. And so I did the contract for eastern Ontario, and this is the dot matrix output of what we found. We had one shell from down here on Westcott Beach in New York State, and two shells actually from Jones's Falls on the Cataraqui branch of the Rideau Canal. And it was, Arthur in his book says that in Lake Ontario drainages, this was mostly down here around Prince Edward County. Now, this $6,500 contract is like the proverbial joint passed out by drug dealers in a school play yard to get people hooked, and probably the best investment the Ministry of Natural Resources ever made, because it got us hooked on freshwater mussels. And one of the things we found was that despite this wide-ranging exploration we've done all around Canada, that eastern Ontario hadn't really been surveyed. I mean, this is not this far southwest, but around Ottawa, the mussels hadn't really been surveyed since 1882. And so we found an awful lot of stuff that hadn't previously been known. This is the creek, our Kempville Creek in Oxford Mills, and we found variants within the common genera that just were not represented in museum collections. And I thought I was losing my mind at one point because I couldn't decide what some of these things were even to the genus level. But it's just that they were variation within a genus that was outside the bounds of what was in the museum collections. So this is this is doing a bridge. In this case, I'm not doing the bridge, I'm just sitting watching other people do it. But we sort of resolved to try to get to every bridge in eastern Ontario and as far northwest and northeast and other directions as we could go to find out what was living along the various streams and in the lakes. So this is where we start from, sort of before that one dot at Jones's Falls that I showed you. This was the knowledge of the distribution of Lagumia nazuta in 1996. And basically it's just down here around Prince Edward County. And what I'm going to be talking about is how we've found it in places north of there on the Frontenac Arch. This is Beaver Lake at Aaronsville, and in 1998, Anita Miles and I were trying to get to a meeting in Peterborough, but we left too late, and we phoned, and no, they were going to go home, and so we drove down Highway 41, and right over here, we found Lagumia nazuta shells. And that was the first indication that they were well north of Lake Ontario in the Frontenac Arch. Oh, you didn't take that out. Anyway, this is Mud Puppy Night in Oxford Mills, which I'm not sure how it got in there, but so then a while went by. We went back, and this is a creek in the town of Lynn, west of Brockville, which runs sort of along the edge of the shield It has limestone bedrock in some places and igneous bedrock in other places, and lots of deep, muddy, mucky pools. And in 2005, we found the Gumi and Nazuta shells there. And this was further downstream along the St. Lawrence than they'd previously been known. So this is just going out, doing a bridge, stumbling across the shells. And this is looking upstream along Golden Creek at the place where we found those shells. It's a slow wind. Well, it doesn't wind here, but upstream of here, it's meandering, soft, mucky bottom. And what had happened to the Lagumi and Nazuta is that they'd mostly been in soft, mucky bottom bays of the Great Lakes and wide places and rivers. And these are the places the zebra mussels had done the most damage. So when we found this population, there was only one other population known to be surviving in Ontario, or in Canada, because there were species only found in Ontario and Canada. And that was a very chancy thing in Lake St. Clair, where something about the way the currents moved meant that no zebra mussel larvae got into one patch of marsh. But this is relatively secure. It's a creek that doesn't have any motorboatable waters upstream of it. So there's not going to be anybody bringing a boat from the St. Lawrence, putting it in with zebra mussels. Because these zebra mussels, they can't live in a stream because they don't have this attached to fish adaptation, and each generation is 14 days downstream of the previous generation. This is the other side of Beaver Lake, on the road south from where the Salmon River comes into it. And in 2006, anyway, sometime around there, Beaver Lake is one of these lakes that's completely surrounded by private cottage lots. And so you have very meager public access to the water. But anyway, I waded out there, found a whole lot of zebra mussels and a few Lagumi and Nazuta shells, which showed that Lagumi and Nazuta had been abundant in Beaver Lake before the zebras. Then in 2007, the Committee on the Status of Endangered Wildlife in Canada, COSEWIC, or COSEWIC, if you pronounce it the other way, came out with their report on Lagumi and Nazuta and said it was endangered. As well they might, because they only had our Lynn Creek population and this population in Lake St. Clair that was known to survive. But the interesting thing about the COSEWIC report, to get back to the question of the support for exploration, is that while the COSEWIC report is being written, even if you discover the second and the only secure population in the country, there's no official funding to support you to go down and concentrate on it and find out more about it. Because the report is still in preparation, it doesn't have a status yet. So that's a picture of me at work in the Frontenac Axis. It's actually not representative of what we've done, because it's only this summer that we really started to take the canoe out and paddle around. We've been mostly just doing bridges. So the situation in Lynn Creek and Golden Creek, where we found the Lagumi and Nazuta, is one where you've got these two creeks come together, and they were sources of water power for 19th century industrialization of the Lynn Valley, but they both go down falls of about 6 meters height. This is Lynn Falls, which is on Golden Creek, and above them there's either no freshwater, no unionid mussels, or else the one commonest sort of beaver flood species. But below that, then there's 8 or 10 species downstream, and including the Lagumi and Nazuta. So this is a natural biogeographic barrier, and you can stand at Lynn Falls and think that no fish has ever come up there since the Champlain Sea receded. And this is a picture of Golden Creek downstream where the mussels are found. It doesn't really look any different than the falls, but the just difference is that there isn't that barrier. Now, which one is this? Okay, this is, see, this comes of not having reviewed this beforehand. Yeah, I guess this is Macintosh Mills, eh? Macintosh Mills. Okay, this is to represent. Yeah, no, this is Graham Lake, and this is a creek that runs from Graham Lake to Charleston Lake. There, get oriented. This is Macintosh Mills, and then the point of this slide is that the Center Lake, Graham Lake, and Temperance Lake are sort of a complex of shallow lakes that might really be good habitat for Lagumia nasuta, but they're completely hedged around with private property with one boat launch. Well, actually 2 boat launches, but we just haven't gotten the canoes in there to see what's in the lake. And then there's this gorgeous creek that runs down to Charleston Lake, but this is as close as a road gets to it. So we're going to have to put a canoe in there and paddle downstream in order to see what's living along it. And there may be Lagumia nasuta. I mean, there may be, 6 kilometers of this really endangered species that nobody has found because nobody's been in to look for it. When it comes to water bodies, there's a huge number of water bodies to investigate, and they all have different fauna of mussels. This is Grenadier Island in the St. Lawrence, and you can see the international, these are all Google map, or Google Street View or map. So this is in the St. Lawrence River, which is all, totally invaded by zebra mussels, but there is this one internal creek, which, despite a small number of hints from me, Parks Canada hasn't gone to investigate to see if they've got an endangered species in this creek, which is totally surrounded by parkland. And so we've been going back to Beaver Lake, and this is the lake that's just drains into Beaver Lake. It's only separated by about 100 meters. It's called Inglesby Lake or White Lake. And over the past 3 years, we've been to the one public access. There's 30 meters of public access there. We had a canoe there last fall, but it was getting to be 6 o'clock in the evening in November, and we didn't, or I guess it was October, but anyway, it was too late to put a canoe in and paddle around. But this is a Lagumia nasuta shell from a presumably surviving population. Just because this lake does November of last year. This is